I have a dream that one day
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
In this lesson on the laws of exponents, we're going to look at the proof of each of the 8 laws. Then, together with some basic examples, practice questions, and a worksheet in the end. When we write a number in the form a to the m, a is called the base, and m is called the power or index. Not both a and m can be 0. In other words, 0 to the 0 is considered to be undefined. Let's look at the definition of an exponent. A to the m means that we are multiplying a by itself m times. Let's take an example. 2 cubed is equal to 2 times 2 times 2. In other words, 2 multiplied by itself 3 times, and we know that this is equal to 8. The first law of exponents says a to the m times a to the n equals a to the m plus n. In other words, when we multiply two numbers with the same base, we can add the powers. Let's take this example. Let's say we have 2 cubed times 2 squared. Since the bases are the same and we are multiplying, we can add the powers, so it becomes 2 to the power of 3 plus 2, which is equal to 2 to the 5, and this equals 32. Let's try and gain a better understanding of why the first law would work by looking at the previous example. When we say 2 cubed times 2 squared, we know that 2 cubed is 2 multiplied by itself 3 times, and 2 squared is 2 multiplied by itself twice. So, when we say 2 cubed times 2 squared, we're actually multiplying 2 by itself, a total of 3 plus 2, which is 5 times. Therefore, 2 cubed times 2 squared is the same as 2 to the power of 3 plus 2, in other words 2 to the 5, which is 32. So here's the formal proof of law 1. You should be able to understand this better after the previous illustration. A to the power m times a to the power n means that we are multiplying a by itself m times, and then again n times. In other words, a total of m plus n times. So that's equal to a to the power of m plus n. We now want to look at a couple of examples that show the basic application of the law 1 of exponents. In the first example, we have x to the negative 3 times x to the 5. Since the bases are the same and we are multiplying, we can apply law 1 and add the powers. So it comes to x to the negative 3 plus 5, which of course is x squared. In the second example, we have b to the 7 times b to the negative 4. Applying rule 1 or law 1, we can add the powers, so it's b to the 7 plus negative 4. The brackets mean multiplication, and we know that a plus times a minus is a minus, so it's b to the 7 minus 4, which is b cubed. Here we have y to the negative 2 times y to the negative 1. Adding the powers, it's going to be y to the negative 2 plus negative 1. A plus times a minus is a minus, so it's y to the negative 2 minus 1, and minus 2 minus 1 is minus 3, so it's y to the negative 3. So we have x to the 1 minus p times x to the 1 plus p. We can add the powers, so it's equal to x to the 1 minus p plus 1 plus p. Minus p cancels with plus p, and we are left with x squared. We simply add the powers of the a's, b's, and c's respectively. So it's a to the 2 plus 1 times b to the 3 plus 2 times c to the 1 plus 2. And this gives a cubed, b to the 5, c cubed. You should pause here and try this question before looking at the answers. It says, complete each of the following, and in number 1 we have m to the minus 2 times m to the 7. Because the bases are the same, we can add the powers. So it's going to be m to the minus 2 plus 7. And of course, minus 2 plus 7 is 5. So it's m to the 5. Here we can multiply the numbers. 5 times 2 is 10. And in adding the powers, it will be 3 plus 4, which is 7. So 10 times p to the 7. We can multiply the numbers here first. 3 times negative 2 is negative 6. Then there's a 1 here that we don't write as a power of a. So a to the 1 times a squared. Adding the powers, we get a cubed. And the same with the b's. B squared times b to the 1 is going to be b cubed. First multiplying the numbers. Once again, it's important to remember that there's a power of 1 here with a 2. So 2 cubed times 2 to the 1. The bases are the same. We can add the powers. So it's going to be 2 to the power of 3 plus 1. So 2 to the 4. Adding the power of the x's. 2 plus negative 1. And the same with the y's. Adding the powers. So it's y to the negative 1 plus 3. We can simplify. 2 to the power 4 is 16. Then 2 plus negative 1 is 2 minus 1. So it's just x to the 1. And negative 1 plus 3 is 2. So it's y squared. The second law of exponents says a to the m divided by a to the n equals a to the m minus n. In other words, when we divide two numbers with the same bases, we subtract the powers. Let's look at a quick example. 3 to the 5 divided by 3 squared. The bases are the same, so we can subtract the powers. So it's going to be equal to 3 to the 5 minus 2, which equals 3 cubed, and we know that it's equal to 27. Now to see why the second law would work, let's look at the previous example a little bit more closely. We know that 3 to the 5 divided by 3 squared is 3 multiplied by itself 5 times, over 3 multiplied by itself twice. In the numerator, we are multiplying 3 by itself first twice, and then again by itself 3 times, or 5 minus 2 times. Now note that the 2 3's in the denominator will cancel with the 2 3's in the numerator, and we are left with 3 multiplied by itself thrice. In other words, 5 minus 2 times. Let's look at the proof of this law. We're going to prove the case where m is greater than n only at this stage. We know that a to the m divided by a to the n is a multiplied by itself m times divided by a multiplied by itself n times. The numerator, in other words a multiplied by itself m times, can be written as a multiplied by itself n times, and then again multiplied by itself m minus n times. The a multiplied by itself n times in the denominator cancels with the a multiplied by itself n times in the numerator, and we are left with a multiplied by itself m minus n times. In other words, a to the power of m minus n. So in the first example here, we have 5 squared divided by 5 to the negative 1. Since the bases are the same and we are dividing, we can subtract the powers. So it's 5 to the 2 minus negative 1. A minus times a minus is a plus. So it becomes 5 to the 2 plus 1, which is 5 cubed, and that's equal to 125. Here we have 7 to the negative 4 divided by 7 to the negative 6. Once again, the bases are the same, so we can subtract the powers. So it's 7 to the negative 4 minus negative 6. Once again, a minus times a minus is a plus. So it's 7 to the negative 4 plus 6, which is 7 squared. Negative 4 plus 6 being 2. And 7 squared, of course, is 49. So we have 3 cubed times a to the 5 times b, all divided by 3 squared times a squared times b to the negative 3. We are dividing, so where the bases are the same, we subtract the powers. So we get 3 to the 3 minus 2 times a to the 5 minus 2 times b to the 1 minus negative 3. Remember that the b has a power of 1, which we don't write. Then simplifying, we get 3 to the power 1, which is just 3, a cubed, and b to the 4, or times b to the 4. Remember 1 minus negative 3 is 1 plus 3, which is 4. Once again, please try these questions before you look at the answers. In number 1, we are dividing and the bases are the same, so we can subtract the powers. So it's x to the 4 less 2, and this of course is x squared. The same in number 2, we subtract the powers, so it's a to the 2 minus negative 3. And of course, a minus times a minus is a plus, so it's a to the 2 plus 3, which is a to the 5. Let's go to number 3. Once again, the bases are the same and we are dividing, so we subtract the powers. So it's p to the negative 1 minus negative 4. And this, of course, is p to the negative 1 plus 4. A minus times a minus being a plus, and this is p cubed. The 3 goes into the 9 thrice, so we have 3 in the denominator. Then we can subtract the powers of the m's, so it's m to the 3 minus 2 times n to the 2 minus 1, and this is equal to m, 3 minus 2 being 1, times n all over 3. Let's go to number 5. We can subtract the powers of the 2's, so it's 2 to the 3 minus negative 1 times x to the 4 minus 3 times y to the 1 minus negative 2. A minus times a minus is a plus, so it's 2 to the 3 plus 1, 2 to the 4, x to the 1, or just x, y to the 1 plus 2, which is y cubed. We can simplify the 2 to the 4. We know that this is 16. So our answer then is 16x y cubed. The third law of exponents says a to the m all to the n equals a to the m times n. In other words, when we have brackets, we multiply the powers. Let's look at one or two examples. 2 cubed all squared equals 2 to the power 6. We multiply the 3 by the 2, which gives us 6. Similarly, y to the negative 4 all to the negative a half is y squared, since negative 4 times negative a half is positive 2. Let's look at why this law would work. We're going to take the example of 2 cubed all squared. Let's first look at what happens inside the brackets. 2 cubed, of course, means that we are multiplying 2 by itself 3 times. Then the square outside the brackets mean that we are multiplying the brackets twice. If we now count the number of times that we are multiplying 2 by itself, we see that it's 6 times, 6 being the same as 3 times 2. Let's look at the proof of this law. A to the m all to the n means that we are multiplying the brackets by itself n times. Inside each of the n brackets, a is multiplied by itself m times. So the total number of times that we are multiplying a by itself is m times n times, which is the same as a to the power of m times n. In the first example, we have p to the 4 all cubed. Multiplying the powers, we get p to the 12. So using the third law, we multiply each power inside the brackets by the power outside the brackets. So we end up with 2 to the 6, a to the 9, b to the 12. Of course, 2 to the 6 we can simplify to 64. There are two things of importance to note about this particular example. Firstly, the power outside the brackets applies to absolutely everything inside the brackets. Then secondly, both the 3 and the y inside the brackets are raised to the power of 1 that we don't write. So applying the third law, we can multiply the powers inside the brackets by the power outside the brackets. So we have 3 cubed, x to the 6, y cubed. And 3 cubed, of course, is 27. Before we go on to the next example, let's look at something important that we need and something you probably already know. A negative raised to an even power gives us a positive. For example, a negative squared is a positive, since 2 is an even number. A negative raised to the power 4 is a positive. And a negative raised to the power 6 is a positive. 6 and 4 being both even numbers. Then a negative raised to an odd numbered power is negative. For example, a negative raised to the power 3 is negative, and so is a negative raised to the power 5. So we have negative m squared in brackets all to the 5. Now, the 5 applies to everything inside the brackets, including the minus. So let's first deal with the minus. Minus m squared is actually minus 1m squared. Of course, we don't write the 1. So applying the power outside the brackets to the minus 1, we know that it's an odd numbered power. So minus 1 to the 5 we know will give us a minus 1. Now we can deal with the m squared. We multiply the power of m by the power outside the brackets, so we get m to the power of 10. So our answer then is negative m to the power 10. So we have negative 3x squared all to the 4. We can first deal with the negative inside the brackets. We know that a negative to the power 4 will give a positive, since 4 is an even number. So we know our answer will be positive. Let's now deal with the 3 inside the brackets. 3 is raised to the power of 1, which we don't write. So multiplying the 1 by 4 outside the brackets, we get 3 to the 4. Lastly, we can deal with the x. We can multiply the power of x by 4 and we get x to the 8. Then 3 to the 4, of course, is 81. Please try these questions on the third law before you look at the answers. In number 1, we have x squared, all cubed. So we have brackets, and we can apply the third law. We can multiply the power inside the brackets with the power outside. So it's x to the 2 times 3, or x to the 6th. Here we have 2x cubed, all raised to the power 4. What's important to note here is that the 2 inside the brackets also have a power of 1, which we don't write. So we must multiply the power outside the brackets with each power inside the brackets. So it's 2 to the 1 times 4, or 2 to the 4, x times 3 to the 4, which is x to the 12. And of course 2 to the 4 is 16, so it's 16x to the power of 12. Once again, the 5 here has a power that we don't write. We multiply the power outside the brackets with each power inside the brackets. So it's 5 to the 1 times 2, or 5 squared, a to the 6th, b to the power of 8. And 5 squared is 25, so it's 25 a to the 6th, b to the 8th. Once again, we apply the power outside the brackets to each power inside. So negative 2 times negative 1 is positive 2, and negative 1 times negative 1 is positive 1. So it's just p. 4 squared, of course, is 16. So our answer then is 16p. Many students will make a mistake here. What's important to note is that the application of law 3, or rather law 3, does not apply across a plus or a minus. So many students here will write the following. They'll say it's a to the 2 times 2, so a to the 4, plus b to the 2 times 2, so b to the 4. This is definitely very wrong. As we mentioned, this law can't apply, or the power outside the brackets can't apply across a plus or a minus. We have to use another method to solve this problem with. So the way to go here is basically to square out the brackets. So we're going to say this is a squared plus b squared times a squared plus b squared. And when we multiply this out, we get a to the 4 plus twice a squared b squared plus b to the 4. In other words, we are squaring out a binomial here. The fourth law of exponents states a over b all to the m equals a to the m over b to the m. In other words, when we have a fraction raised to a power, we apply the power to both the numerator and the denominator. To take an example, 2 over 3 all to the 4, we apply the power of 4 to the numerator, so we get 2 to the 4, and then we apply the power to the denominator, and we get 3 to the 4. and this equals 16 over 81. Let's look at the proof of the fourth law. A over b to the m means that we are multiplying the fraction a over b by itself m times. Now we're going to use a basic rule of algebra that says when we multiply fractions, we multiply the numerators and we multiply the denominators. For example, a over b multiplied by c over d equals a times c over b times d. Now, applying this to the fraction a over b multiplied by itself m times, we can multiply the numerators. In other words, a times a multiplied by itself m times over b multiplied by itself m times. So we have one fraction with m a's in the numerator and m b's in the denominator. Now, by the definition of an exponent, a multiplied by itself m times is equal to a to the m, and b multiplied by itself m times is b to the m. So we end up with a to the m over b to the m. So in the first example here, we have 3x over 4y all squared. Using the fourth law, we can apply the power to the numerator and to the denominator. Now we can use law 3 and apply the power to each term inside the brackets in the numerator as well as the denominator. So we have 3 squared x squared all over 4 squared y squared. 3 squared is 9 and 4 squared is 16. Here's another basic example using the fourth law of exponents. We have m squared over n cubed all to the 4. Using the law 4, we can apply the power of 4 to the numerator and the denominator. So we have m squared all to the 4 over n cubed all to the 4. Then, using the third law, we can multiply the powers into the brackets. So we have m to the 8 over n to the 12. Let's look at the last example on this law. What's important to note here is that we always simplify first inside the brackets. So we can square out the 2 to become 4. We can also use the second law to subtract the powers of the numbers that we are dividing by with the same base. So it's going to be a to the 5 minus 3, b to the 2 minus 1. This simplifies to 4a squared b all over 5 and all raised to the power of 2. Now we can apply the fourth law to both the numerator and the denominator. So it's 4a squared b all squared all over 5 squared. We can now use the third law and multiply the powers inside the brackets with the power outside the brackets in the numerator. So we have 4 squared, which of course is 16, a to the 4 b squared all over 25. Please pause here and try this question before you look at the answer. In number 1, we have 5a over 9b all squared. We can straight away apply law 4 and apply the power of 2 to both the numerator and the denominator. Now, inside the brackets, we have ones here as powers that we don't write. So we now apply law 3 and apply the power outside the brackets to everything inside the brackets. So it's 5 to the 1 times 2, 5 squared. A to the 1 times 2, a squared. 9 to the 1 times 2 is 9 squared. And then we have b squared. And this simplifies to 25a squared all over 81b squared. In number 2, we have a slight complication in the sense that we have a negative inside the brackets. Now, the negative, by the way, means that we have -1 as a coefficient here. What's important to know here is that any negative number raised to an odd numbered power will be negative, and any negative number raised to an even numbered power will be positive. In this case, the sign inside the bracket is negative, and it's raised to an odd numbered power, so we know that the answer is going to be negative. Now we can apply law 4 to both the numerator and the denominator. And in using law 3, we can multiply the powers because we have brackets in both the numerator and the denominator. In number 3, we once again have a negative inside the brackets, but in this case it's raised to an even numbered power. So we know the answer is going to be positive. We can apply law 4 to both the numerator and the denominator. Now, once again, we have a power of 1 here with a 3. So then applying law 3, we multiply the powers. So we get 3 to the 4, q to the 8th. And we can simplify this. 3 to the 4 is 81. And we have q to the 8 as well in the denominator. In number 4, we have a choice as to how we want to proceed. We can either start straight away by applying law 4 and applying the power of 2 to both the numerator and the denominator. Or we can go the BODMAS route and simplify inside the brackets first. So let's do that. 3 squared we can write as 9. M to the 4 divided by m squared. Using law 2, we can subtract the powers. So we get m squared and n squared as well. Now we can apply the fourth law. So it's going to be 9m squared n squared all squared over 4 squared. And using rule 3 or law 3, we can apply the power of 2 to everything inside the brackets by multiplying the powers out. This is 9 to the power 1. So we get 9 squared, m to the 4, n to the 4. 4 squared is 16. And 9 squared is 81. So we have 81 m to the 4, n to the 4, all over 16. The fifth law of exponents says that any non-zero number raised to the power 0 equals 1. Recall that right at the beginning of this topic, we said that 0 to the 0 is undefined. So this law holds provided that the base a is not 0. Let's look at a couple of examples. 3 to the 0 equals 1. X to the 0 equals 1. Here, everything inside the brackets is raised to the power 0, so it's equal to 1. Note that we don't even have to simplify inside the brackets to get to the answer. This is a nice easy proof. The key here is to write a to the 0 as a to the m minus m. Then we can use the second law. We know that a to the m minus m can be written as a to the m divided by a to the m. And any non-zero number divided by itself, of course, is 1. We want to look at two examples of importance based on this law. These are examples that a lot of students often get wrong. The first one is 5x to the 0. Now, note that the power 0 applies only to the x and not to the 5. So it's equal to 5 times 1, x to the 0 being 1. And this equals 5. In the second example, we have 5x in brackets to the 0. Now, here the power applies to everything inside the brackets. So 5x all to the 0 is equal to 1. Do try this question first before you look at the answers. In number 1, we have 7p to the 0. The power of 0 applies only to the p here and not to the 7. So this is 7 times 1, p to the 0 being 1 by the fifth law. And of course this is 7. In number 2, we have brackets. So everything inside the brackets are raised to the power 0. So this is simply going to be 1. In number 3 here, the power of 0 applies only to the y. So it's going to be 3x to the 5 times 1. Y to the 0 being 1. And this of course is 3x to the 5. In number 4, we once again have brackets. So everything inside the brackets must be raised to the power 0. We don't even have to simplify inside the brackets first. This is simply going to be 1. Coming to the sixth law of exponents, it says a to the negative m equals 1 over a to the m. In other words, if the power is negative, we can make it positive by writing it as 1 over or inverting the exponent. One or two examples. 3 to the negative 2 is 1 over 3 squared, which is equal to 1 over 9. Similarly, x to the negative 4 is 1 over x to the positive 4. To prove this law, we write a to the minus m as a to the 0 minus m. Now we use the second law, so we know that a to the 0 minus m by the second law is a to the 0 over a to the m. Then using the fifth law, we know that a to the 0 is 1. So then we end up with a to the minus m being equal to 1 over a to the m. Here we have 3x to the negative 1. The first thing to note here is that the power of negative 1 applies only to the x and not to the 3. So using law 6, we can write x to the negative 1 as 1 over x. So we have 3 times 1 over x. Now we're going to use a basic rule of algebra. If we have a times 1 over b, then we can write the a as a over 1. So we have a over 1 times 1 over b. We multiply the numerators and we multiply the denominators. So we have a over b. Using it here, we can write 3 as 3 over 1. So we have 3 over 1 times 1 over x. Then multiplying the numerators and multiplying the denominators, we get 3 over x. So we have 3x in brackets to the negative 2. Important to note here that the power of negative 2 applies to everything inside the brackets. So then using law 6, we can write it as 1 over 3x all squared. Now we can use the third law that says we can multiply the powers inside the brackets by the power outside the brackets, and we get 1 over 3 squared times x squared, which of course is 1 over 9x squared. Here we have a choice as to how we can proceed simplifying this expression. We can either start with law 3, in other words, we can multiply all the powers inside the brackets by the power outside the brackets, or we can go straight to law 6. So let's go to law 6. Of course, the brackets mean that everything inside is raised to the power of -2. So we can write it as 1 over. Now we can apply law 3 and multiply each power inside the brackets by the power outside the brackets. So it's going to be 1 over 2 to the 6, p to the 4, q to the 10. And of course, 2 to the 6 is 64. So we have 1 over 64, p to the 4, q to the 10. Once again, we can start with either law 3 or law 6. We're going to use or start with law 3 in this case, just to be able to show how one would proceed doing that. So then applying law 3, we can multiply the powers inside the brackets with the power outside the brackets. So we get 5 to the -3, a to the 12, and b to the -6. Now we're going to use law 6 to the factors in this expression that has negative powers. So 5 to the -3 would become 1 over 5 cubed, and b to the -6 would become 1 over b to the 6. Also remember that a to the 12 is the same as a to the 12 over 1. So now we multiply the numerators and we multiply the denominators. So we get a to the 12 divided by 125 times b to the 6. Please try these questions before you look at the answers. In the first one, we have 4x to the -2. Now, the power of -2 applies to the x only and not to the 4. So then using law 6, we can write it as 1 over x squared. And remember that the 4 is actually 4 over 1. So then multiplying the numerators, 4 times 1 is 4. And 1 times x squared is x squared. In number 2, the power of -2 applies to everything inside the brackets. So using law 6, we can write it as 1 over all of 4x to the +2. And now we can apply the power outside the brackets to everything inside the brackets. So it's 1 over 4 squared, x squared, and of course this is 1 over 16 x squared. In this question, once again the power of -4 applies only to the a. So we can write this 3 times 1 over a to the 4, in other words to the +4, using law 6. And it's still times b as well. Both the 3 and the b can be written over 1. So now we just multiply the numerators. 3 times 1 times b is 3b. And 1 times a to the 4 times 1 is a to the 4. In the fourth question here, we have a choice. We can start either with law 3 or with law 6. We're going to do both. Let's first look at when we start by using law 3. We can apply the power outside the brackets to everything inside the brackets. So -1 times -4 is +4. There's a 1 here as a power of t that we don't write. So 1 times -4 is -4. And then -3 times -4 is 12. Now 2 to the 4 is 16. And we can apply law 6 here and write it as 1 over t to the +4. All times r to the 12. Once again, This is 16 over 1, r over 1. We can multiply the numerators. 16 times 1 times r to the 12 is 16r to the 12. And then multiplying the denominator out, or the denominators, 1 times t to the 4 times 1 is t to the 4. So in this case, we've started with applying law 3. Let's see what happens when we start by using law 6. So this will be the alternative way of doing this. So we can write it as 1 over all of 2 to the negative 1 t r to the negative 3 all to the positive 4 using law 6. Now we can use law 3 and apply the power of 4 inside the brackets in the denominator. So negative 1 times 4 is negative 4. T to the 4, r to the 12th, or rather to the negative 12. Now, both 2 and r are raised to negative powers. So we simply take it to the top as 2 to the positive 4, r to the positive 12, all over t to the 4. And then finally, 2 to the 4 is 16, r to the 12 over t to the 4. We now come to law 7 of exponents. It says a over b to the negative m equals b over a to the positive m. In other words, when we have a fraction raised to a negative power, we can invert the fraction and the power becomes positive. Let's look at one or two examples. 3 over 4 to the negative 2. We can use law 7 and invert the fraction and the power becomes positive. So it's 4 over 3 to the positive 2. Now we can apply law 4 and apply the power to both the numerator and the denominator. So we get 4 squared over 3 squared, which is 16 over 9. Let's look at x over y to the negative 3. Using law 7, we can write it as y over x to the positive 3. And then using law 4, we can apply the power to both the numerator and the denominator. So we get y cubed over x cubed. Let's look at the proof of the seventh law. A over b to the negative m can be written as a to the negative m over b to the negative m. Here we are applying the fourth law. In other words, we are applying the power of negative m to both the numerator and the denominator. Now we can apply the fifth law. So a to the negative m we can write as 1 over a to the m, and b to the negative m we can write as 1 over b to the m by using the fifth law. Now we have a fraction divided by a fraction, so we multiply the numerator by the inverse of the denominator. So it's 1 over a to the m multiplied by b to the m over 1. Then multiplying the numerators and the denominators, we get b to the m over a to the m. We can now use the fourth law again. B to the m over a to the m we can write as b over a all to the m. In the first example on using law 7, we have 3x over 2y all to the negative 4. Applying law 7, we can invert the fraction, so we get 2y over 3x, and then the power becomes positive. So it's 2y over 3x to the positive 4, and this is using law 7. Now we can apply law 4, which says we can apply the power outside the brackets to both the numerator and the denominator. So we have 2y all to the 4 over 3x all to the 4. Now we can apply law 3, which says the power outside the brackets can be applied to everything inside the brackets, in both the numerator and the denominator. So we have 2 to the 4, y to the 4, over 3 to the 4, x to the 4. And this simplifies to 16y to the 4 over 81 x to the 4. Here we have an algebraic fraction raised to the power of -1. Applying law 7, we can invert the fraction and the power becomes positive. Note that when 2 to the -2 goes into the numerator, the sign doesn't change when we apply law 7. Now we can drop the power of 1 because we know that anything raised to the power of 1 remains the same. We have a 2 to the -2 in the numerator. We can use law 6 and take it into the denominator as 2 to the +2. In the next step, we simply square out the 2 and the 3. So we get b cubed over 4 times 9a to the 5. And then simplifying, we get b cubed over 36a to the 5. Please try these questions before you look at the answers. In the first one, we have x over y to the -1. Using law 7, we can invert the fraction and it becomes y over x to the +1, but we don't have to write the power if it's 1. In number 2, once again, we can apply law 7 and invert the fraction. The power becomes positive. Now we can apply the power to both the numerator and the denominator. And then 3n squared, we can apply the power outside the brackets to everything inside the brackets. So it's going to be 3 squared n squared. And we do the same in the denominator. It's going to be 2 squared m squared. And this, of course, is 9n squared over 4m squared. Let's look at number 3. We have a choice as to how we can start here. We could first simplify inside the brackets or straight away apply law 7 at the beginning. So let's do that. So I'm going to invert the fraction. And of course the power becomes positive and it's to the +1. Now we can simplify. The 4 to the -2 in the denominator, we can take to the numerator and the power becomes positive. So it becomes 4 squared. We can subtract powers where the bases are the same. So it's p to the -1. And of course there's a 1 here with a p in the denominator that we don't write. So it's -1 minus 1 q. And once again, there's a power of 1 here that we don't write. So it's q to the 1 minus -3. 3 squared is 9 times 4 squared, which is 16. P to the -2 q, 1 minus -3 is 1 plus 3, which of course is 4. Now we can multiply 9 and 16, and that's 144. And the p to the -2 we can take into the denominator, and the power becomes positive. And of course, in the numerator, we still have q to the 4 as well. The eighth and last law of exponents deals with roots, also known as surds. It says that the nth root of a to the m equals a to the m over n. Let's take one or two basic examples. Let's say we have the square root of 3. Now first note that the root has a 2 associated with it that we don't write, and the 3 has a power of 1 associated with it that we don't write. So using this law, we can write the square root of 3 as 3 to the power of a half. Let's take a second example. Let's say we have the cube root of x squared. Using this law, we can write it as x to the 2 over 3. In order to make sense of law 8, we first want to look at what we mean by the root of a number. Let's take the square root of 9. When we write the square root of 9, we are asking ourselves what multiplied by itself gives 9. And of course the answer is 3, since 3 multiplied by itself gives 9. Let's take the cube root of 8. Here we are asking what multiplied by itself 3 times gives 8. And of course the answer is 2, since 2 multiplied by itself 3 times gives 8. Let's now look at the nth root of a. Here we are asking what multiplied by itself n times gives a. Now the nth root of a equals a to the 1 over n, since a to the 1 over n multiplied by itself n times gives a. And this of course is by law 3. Now that we've shown that the nth root of a equals a to the 1 over n, we can easily show that the nth root of a to the m equals a to the m over n. We simply replace the a in this equation by a to the m. So the nth root of a to the m will equal a to the m all to the 1 over n. And in using law 3, we can multiply the powers because we have brackets, and we get a to the m over n. So we have the fifth root of x to the 10. Using law 8, we can write it as x to the 10 over 5, and this simplifies to x squared. So here we have a cube root. We drop the cube root by dividing all the powers underneath it by 3. Simplifying, we get 4 squared, a, b to the negative 4. Now we can take the b to the negative 4 into the denominator as a positive power. So we have the fourth root of 81p to the 8th q squared. The first thing to note here is that 81 has a power of 1 associated with it that we don't write. We can drop the root by applying law 8 and dividing all the powers under the root by 4. So we have 81 to the 1 over 4, p to the 8 over 4, q to the 2 over 4. We can simplify the 81 to the 1 over 4 by taking prime factors of 81. So the smallest number into 81 is 3, and it goes 27 times. The smallest number into 27, 3, and it goes 9 times. The smallest number into 9, 3, and it goes thrice. And finally, the smallest number into 3, 3, and it goes once. So 81 can be replaced by 3 to the power 4. We can now use law 3 and multiply out the powers, and the 4's cancel. So we end up with 3p squared q to the 1 over 2. Let's look at the last example on law 8. Here we have the square root of p squared plus q squared. What some students may be tempted to do is to apply law 8 in the following way. To divide all the powers under the square root by 2, and so we end up with p plus q. However, this is very wrong. Law 8 can't be applied across a plus or a minus. So the square root of p squared plus q squared is simply equal to the square root of p squared plus q squared. And there's no way in which we can simplify this expression. Please try this question before you look at the answers. In the first one, we have the square root of p to the 12. Now, we know that there's a 2 associated with the square root that we don't write. So then applying law 8, we can divide the power by 2. So we end up with p to the power of 6. Here we have the square root of 9x to the 4, y to the 8. We can first find prime factors of 9. The smallest number into 9 is 3, and it goes thrice. The smallest number into 3, 3, and it goes once. So we know that 9 can be written as 3 squared. We can put this under the square root. So 3 squared, x to the 4, y to the 8. Now we can apply law 8 and divide all the powers by 2. So we get 3 to the 2 over 2, x to the 4 over 2, y to the 8 over 2. Here we have the cube root of 27m to the 9, n to the 6. Once again, we can find prime factors of 27, and we see that it comes to 3 cubed. Then we have m to the 9, n to the 6th. And now applying law 8, we can divide the powers by 3. So 3 to the 3 over 3 is 3 to the 1. M to the 9 over 3. N to the 6 over 3. In number 4, we have the square root of x squared minus y squared. Now, this is definitely not equal to x minus y. Remember that we can't apply law 8 across a plus or a minus. So the correct answer here will be the square root of x squared minus y squared. In other words, there's nothing more we can do here to simplify this expression.